season starts here, the Vancouver Boat Show.
These sort of boat shows in person, and we love it. We love sharing our passion for boating with all of you fellow boaters and meeting you and talking about what's upcoming for the year and what projects.
All right, so we are experiencing some technical difficulties, but it shouldn't take much longer at this point. Thank you for your patience. Let's try this again. Finally, can somebody confirm with me in the chat window that you can see the video now? Excellent. Thank you so much for your patience. Here we go.
Hi, Jeff Cote here with Pacific Yacht Systems. First off, let me thank the Vancouver Boat Show and Boating BC for hosting this virtual boat show. Naturally, we normally do these sort of boat shows in person, and we love it. We love sharing our passion for boating with all of you fellow boaters and meeting you and talking about what's upcoming for the year and what projects we're going to do. But this year we're doing what we can with what we have. So it's going to be a virtual boat show, and thanks for watching this presentation. And what we're going to be talking about is designing an electrical system for your boat.
All right. So now I'm just going to switch the video to a second device. And again, I will appreciate your patience for that. And this will improve our experience.
Hi, Jeff Cote here with Pacific Yacht Systems. First off, let me thank the Vancouver Boat Show and Boating BC for hosting this virtual boat show. Naturally, we normally do these sort of boat shows in person, and we love it. We love sharing our passion for boating with all of you fellow boaters and meeting you and talking about what's upcoming for the year and what projects we're going to do. But this year we're doing what we can with what we have. So it's going to be a virtual boat show, and thanks for watching this presentation. And what we're going to be talking about is designing an electrical system for your boat. By the way, I'm hoping this is going to be clear to all of you as the presentation goes along, is that we here at PYS and myself here, Jeff Cote, have an incredible passion for boating. Boating is not a hobby, it's a lifestyle. And today what I'm going to be sharing with you is the lessons and the experiences that we have being invited on all of your boats and sharing the lessons learned through all those experiences. I'm a systems design engineer by education. Of course, as we know, boating is humbling, and I learned, like all of us, a lot of it by owning a boat, by working on boats. You don't learn this stuff in school, unfortunately. I wish there was one. I surely would have attended. But taking an approach and a systematic approach on how you go about choosing and selecting the pieces and the bits that fit on your boat is an essential approach on how we do things here at PYS, and I'm going to be sharing that with you today. I'm the owner-operator of Pacific Yacht Systems here in Vancouver, British Columbia. We also own another company called Roton Industries, and those two companies are strictly focused with marine, recreational, electrical, and electronic systems. Team almost of close to 20 people now dedicated just to this purpose, and we're really humbled and we feel privileged to, again, be able to serve and be of service to boaters. So that's a big thing. Certification is another important thing. You'll notice here I've got NMEA and also ABYC. Those are both sort of bodies that we definitely include when we're thinking about our solutions. So all of us can be very creative in life, right? We can do things our own way. But there's something to be said about doing things in a way that is easily recognizable from other boaters. So that's something that's really important, and we can't lose sight of that. So that's why the standards are important. They're predictable. They're easily understood by others. So ABYC and NMEA are a big part of our work and certainly what I'm going to be sharing with you today. We used to write articles for Tech Talk, Hotwire, and all those articles for, did almost 10 years with Pacific Yachting, over a year and a bit with Hotwire. All those articles are actually on our website. And even if you want to read about something that was published a year ago or 3 years ago, you can find all those PDFs and even as HTML web pages on our website. We've got a great little search bar. You put it in there, you can find that as well. I'm a boater, and that's basically the definition of who I am. There's nothing about my life that isn't about boating, luckily. We love boating. We love the cruising grounds, being on the water, everything about it. And it's an incredibly rewarding way for us to enjoy nature and to also spend quality time with each other. So the next slide here, where we're talking is a little bit about the company, Pacific Yacht Systems, and I mentioned that a little bit earlier. So we specialize in marine, electrical, and electronics. So our sort of motto in life is expertise through repetition. I remember starting my business almost 15 years ago. I was so overwhelmed. I was like, there's no way that I can ever get a sense of being truly good at everything about a boat. It's humbling. So what we decided to do is said, okay, well, if we're not going to be great at everything, then let's specialize. Let's choose a few subsections about a boat. And today what we're going to be talking about is marine electrical. We do local work on boats here in British Columbia. So we have obviously boaters from Washington State and even California, Oregon that are bringing their boats to us here in Washington State, either as they come up and enjoy the phenomenal cruising grounds that British Columbia or on their way to Alaska have to offer. So that's a big thing. But another important point, and it's worth noting, and this is what I'm putting over here, last year alone, we did about 400 electrical projects where we're doing design and consultation. And this is essential because our recommendations of what our lessons learned are based on experience. So we're humbled, again, we get to work on the consultation and design on boat owners that are around the world. Venezuela, Abu Dhabi, Singapore, Indonesia. I think every state in the state, we probably have dealt with a boater in every single state. I'm dealing right now with a boat owner in Kentucky. Boat owners are everywhere. They're passionate and they want to do things. Some of us, certainly, I'm one of them, want to do things with a plan. They don't want to just build and then think as they go along. They're trying to say, okay, if I'm going to build a house, first thing is, what house am I going to build? Versus grabbing a hammer and some wood and just starting to build. So building with a plan is an essential component of what we offer, and we offer these through our design, our consultation and design services. Lastly, if you're curious and you're a geek too, and I have an inner geek inside of me, I recommend and strongly encourage you to check out our other YouTube videos. We've got about 250 YouTube videos. We're posting every other day or even more often than that. and we're sharing our knowledge with other boaters, and in the hope of giving all of us and enabling us to fulfill our dreams, which is out there boating in a safe and reliable and comfortable boat. So that's a really big part. And the other thing too, our website is right here, Pacific Yacht Systems, pysystems.ca. And you can find schematics, design, and there's over, I think we're almost close to 1,100 web pages, and it's not salesy at all. It's information for boaters so you can absorb, so that you can, I always say this is worth saying. Before you do, one must educate themselves or plan. So it's not do it yourself, it's educate and then do. And so our website is a means to that as boaters to prepare ourselves so that we only, hopefully, do it only once. And the worst thing is building on a boat and then having to undo. So, okay, a little bit kind of pretty cool. The slides as well are going to be published on our website as a PDF. So there's going to you can actually get them there as well. And let's remember, for the purpose of sharing information today, the diagrams that I'm going to be showing are not necessarily detailed diagrams, but what I consider conceptual diagrams. It's a way for me to try to convey information to you, the boater, in a way that is visual and not just with words, but it's not necessarily the way you would just build a boat. I'm sharing a concept more than a specific build diagram, okay? All right, so with that, we're going to get started. Wow, right? So here you go. This is basically the possibilities of your boat. If this feels overwhelming, join the club. I remember even creating the schematic or this conceptual diagram, and I was like, holy cow, how many possible things are there on a boat? And here we've got, like, what are the common things? You're talking about, I've got a charger. Chargers are pretty common. Most boats have a battery charger to recharge the batteries. Or certainly all boats, not all, because there's always an exception to every rule. Electrical propulsion vessels are not going to have an alternator, but most of us, 99.9% of us that have sort of an engine, diesel or gasoline, are going to have an alternator. So we've got alternators, we've got chargers. Some of us are going to have certainly fuse blocks on board, right, to power the bilge pumps, carbon monoxide. And then we're going to have loads, the DC panel. Like, who doesn't have a DC panel on their boat, or an AC panel? We might have inverters, chargers, inverter charger. So there's all these different things that happen on their boat, and today we're going to be going through all of them to understand their place and where they belong. Now, before we move forward, I want to emphasize, and this is, I know the words are going to be a little bit, they don't mean much, but listen to them. I'm going to be using the concept of repetition to try to really hammer this concept of unswitched distribution and switched distribution. And if you look on the diagram here that I'm sharing, unswitched distribution is right here, and then switched distribution is on the other side, on the right hand of the slide. Unswitched distribution means that it's effectively an always-on connection. It's always connected to the battery. And some of us are going to see these batteries that have like 5, 6, 10. I think the most I've ever seen is like 14 connections on a battery post. It's not to say that some boats don't have 100 connections. It's generally those connections are further down, right? So it's very important to think about things that need to always be on and things that can be switched off. So always on is called unswitched, right? There's always power there. It's always energized like a battery. A battery always has power at the positive post, unless it's drained, of course. And then there's another side of the boat, which is called the switch distribution. That's the one that could be on or could be off, and you as the boater, as the operator, have the ability of turning a switch to turn that power on or off. So the unswitched distribution is on the left-hand side, and the switch distribution is on the right-hand side, okay? We're going to be repeating that concept a lot. So let's get started. So here's an AC overview of a boat, and by the way, AC in terms of an overview is even a big boat like a 100-footer, 150-footer, we're talking 50 meter, 30 meters, are just an extension of that. The AC on a boat is not necessarily, it can be pretty extensive, but it's not complicated. So let's have a look a little bit about the concept of an AC system on a boat. AC stands for alternating current, It's basically what we're sort of familiar with in our homes. These are these typical outlets that we have. You plug in the kettle, you plug in a heater, you plug in your fridge, an oven, whatever, dishwasher, battery charger. These are these little outlets that we have. And some of them could be hardwired or you plug in, but regardless, it's basically either 120 or 220 volts AC, 50 hertz, 60 hertz, depending if we're in Europe or North America, but it's alternating current, not battery. So where does that alternating current come from? Well, there's multiple sources. Here we've got an example. Most of us are going to have what are called basically shore connections, right? So a shore connection is right here, shore. So shore, some boats have one or two, but most of us are going to have a single AC shore connection, or you'll even have an AC generator. A lot of boat owners out there have an AC generator on board. Good. And here I'm going to, so know that, of course, not all. So are going to have an alternator. So we've got alternators, we've got chargers.
Okay, there was a request to share the slides on the screen, but seeing what the difficulties are with sharing just the video as it is, I think I'll stick to that. So there's a link for the slides in the chat window for you to go to during the presentation or later. And also, like I said, you'll be able to stream this recording after March 1st. So I'll try to get us back to the same spot.
It's not do it yourself, it's educate. That's really important. I know this is hard.
Should be approximately here.
You want your battery bank to be in one physical location. So if you have a house battery bank, you don't want to have half of the battery be at the front of the boat, the fore of the boat, and the other half to be at the aft of the boat. You want that battery bank to be in one physical location. So that's another requirement when you're on the charger. It'd be preferable to go with a seal valve regulated battery than to go with a flooded lead acid battery. And you see that's where this number here firefly for an aft thruster. So now
I think this spot will be closer to where we left off.
now you've got two battery banks for that. Some boats, and it's not even on a 40-foot boat, 45-foot boat, there's some boats that have literally 6 different battery banks on that boat. So that's another factor that you have to think about. Okay, how many battery banks am I going to have on my boat? And then after go through the exercise of even sizing those battery banks. So that's an important thing. Lastly, especially maybe not building a boat, but certainly buying a boat, we have to come into consideration. Is this boat basically mostly running on 220, 120? Is it coming from Europe? Potentially 50 hertz, right out of Europe. In North America, we're on 60 hertz. So those are factors when you're buying a boat or where your destinations are going to be. Are you going to predominantly stay in Europe? Are you going to predominantly stay here in North America or just stay here? So that's going to be a factor when you're choosing what sort of AC appliances you're going to have on your boat. And then you can decide the operating voltage. Is it going to be 120, 220, 50 hertz, or 60 hertz? Okay, by the way, in North America, it's 60 hertz. In Europe, it's 50 hertz, and different jurisdictions have different sort of nominal standards in terms of frequency and voltages. Okay, so next, let's start with this interesting. We'll start with the foundation, is basically what's called energy storage or batteries. You can see from this slide right here, marine batteries come in all sizes and shapes. All sizes and shapes. Here's just a sample of them. You can see they all look differently. They all have different manufacturers do them, different chemistries, and we're going to talk a little bit about that. So realistically, there are two big camps 4 batteries, right? There are what are called flooded lead acid batteries. And these are batteries that we generally had in our cars, and there's certainly 60s, 70s, 80s, 90s. They've been around forever, right? These are batteries, they're ubiquitous, they're everywhere. So that is a lead acid flooded battery, and you can see you can buy that as a starter battery, deep cycle battery, or even a dual purpose battery. It's both. It's a compromise. It's sort of like for some of you that have winter tires or live in a climate where it is cold in the winter time, you might have a set of summer tires, a set of winter tires, or you might have a set of all seasons. So dual purpose battery is sort of an all season type of battery. It's okay at starting and it's okay at deep cycle. It's not great at either, but it's okay. Or another type of battery is this concept of a seal valve regulated battery, and that's this one right here. SVR is the acronym that you're going to see, and then a lot of people use that term to describe 2 different types. Well, there's 3 really. Gel batteries is one of them. AGM stands for absorbed glass mat, or you have foam core AGM, which is basically Firefly. Those 3 batteries, these SVR, gel, AGM, and foam core AGM, are batteries that cannot leak. So they're batteries that can be installed on their sides. They're not flooded. You don't need to top them off. They're maintenance free, and they offer some advantages. So far we've talked about flooded lead acid, seal valve regulated lead acid batteries, and the last one that's gaining some popularity certainly, and if you haven't heard it, you're probably eventually will, is this concept of lithium iron phosphate batteries. Most people in the industry just use the word lithium to describe batteries, and that's also gaining traction, certainly with a higher price point, but there is a merit to do lithium if you meet what I consider the requirements where the high cost is worth it. So really 3 different types of batteries: flooded lead acid, seal valve regulated lead acid batteries, and then lithium batteries, okay? So 3 choices. So let's look a little bit at a table here, and what I was trying to do is, being an engineer, of course, I'm looking pros and cons, weighing, should I do this, should I do that? So we've got a table here, and at the table you can see there's really, at the top I'm putting AGM, Firefly AGM, and then flooded. And notice what I'm trying to do with the dollar signs, like basically the least expensive battery you can buy is called a flooded battery. And then the next level up is an AGM. The next level up after that is Firefly AGM, and after that it's lithium. So know that, of course, not all batteries are priced at the same level. And as you go up in price point, you're getting more and more features. So there is maybe a reason for you as a boater to consider lithium or even consider AGM. Or you might be like some of my other boaters that, they go through the pros and cons. They're like, you know what? For my boat, based on my budget and what I want to do with that boat, flooded lead acid is going to work fine for me. So to help you make that decision as a boat owner, and by the way, I have presentations on an hour just on batteries. If you want to geek out, you go on our website. Even my web developer was saying, I can't put all the content related to batteries on your website. It's the search engine simply can't handle it. Put in the word battery and you're going to get over 200 web pages, 50 videos. It's crazy on just about selecting batteries. This is just a sample to try to give you a little bit of a sense. So now if you look, the big advantage as you choose different batteries is going to be battery life. So battery life is a factor, and you use the term in the industry is called cycles. Cycles is the ability of taking a battery from full to some depth of depletion and how frequently you can do that. The further down you go, the less cycles you have. So at the top end, if you're 100% battery and you bring it down to 99%, you might use that battery 10,000 times, 20,000 times, 30,000 times, and that's what we do in our cars, right? It's crazy amount of life cycles because we don't deplete it much. But if you take that same battery and you bring it down to 0, you might only get 50 cycles, right? So as you go deeper in your depth of discharge, the less cycles you're going to have. So one of the things that the battery manufacturers are considering is like, okay, well, if we're doing 50% depth of discharge, which is from 100 to 50, how many times can I do that? And you'll notice that in terms of lead acid batteries, the one that give the most amount of usable cycles is going to be, of course, the Firefly, The next one after that, you can see, is both the flooded and AGM have similar type of cycles. But here's where it gets interesting, is this usable battery capacity. When you buy a battery, what you see isn't what you get. Unfortunately, it's not that straightforward. Because a flooded lead acid battery is only about a third usable. AGM is about 55% usable. And then a AGM foam core is about 65. For comparison, a lithium is about 80% usable. So even higher usable rate. And that's this concept of usable. The other one too to consider is maintenance. Are you committed to the maintenance of your batteries? Are you going to top off those fluids? Because if it's a deep cycle battery, unlike a starting battery in our cars, they need to be maintained. As the battery is discharged and recharged, as we're recharging, it boils, it heats up. As the battery is boiling, as we're heating it up again, some of the electrolyte, a water component, evaporates, and that needs to be topped off with distilled water to bring the electrolyte to the right sort of mix for sulfuric acid for that lead acid battery. Or do you simply want to have a battery that you don't have to maintain? Well, if that's the case, then you're either going to go to AGM, you're either going to go to gel or foam core AGM, or potentially lithium. But a flooded lead acid battery needs to be maintained. So that's another variable to consider. The other one too is this concept of self-discharge. That means, given if you leave the battery in the corner and you had it in a garage on your boat, no connection, will that battery stay charged or will it discharge over time? AGM and gel batteries self-discharge less, and same with Firefly, than a flooded lead acid battery. So some of us that want the battery to be there, if we're not always have it on the charger, it'd be preferable to go with a seal valve regulated battery than to go with a flooded lead acid battery. And you see this where this number here, you've got 15% of the batteries discharging on per month versus maybe 2% for AGM. So that's one of the reasons why you might consider a seal valve regulated battery. And then also, basically, what are you using the battery for? Are you using it for starter? Are you using it for deep cycle? That's another variable when you're choosing your battery. And lastly, the effect of sulfation. Sulfation is definitely more prevalent in a flooded lead acid battery. And AGM certainly becomes a factor. And then the big advantage of the foam core AGM battery is as you cycle that battery and you're living in that partial state of discharge, that battery doesn't sulfate as much as a normal AGM or flooded battery. That means it doesn't age as fast, and that's where you can get these crazy, unimaginable cycles, like 3,000, 4,000, 4,700 cycles at 50% of discharge. So those are the reasons and the comparisons between an AGM battery, a Firefly battery, and a flooded lead acid battery. But remember, they're all lead acid batteries. So here are some examples of Firefly batteries. You can see these batteries that I'm showing off here are 12-volt batteries. And so they're basically, you can wire them obviously in increments of 12. We've installed them on boats that want 24. We've done a lot of vessels that have electrical propulsion. And those vessels are 48 volts, and certainly the ones we've worked on. So those are some examples. Okay, so let's start now with a little bit of design tips with regards to actually going about with batteries. A little bit of design tips is, of course, when you're going to be installing a battery bank, here's a tip, is make sure that the positive and negative of the battery bank are at opposite ends. That's really important. I know this is hard, but ideally you want your battery bank to be in one physical location. So if you have a house battery bank, you don't want to have half of the battery be at the front of the boat, the fore of the boat, and the other half to be at the aft of the boat. You want that battery bank to be in one physical location. So that's another requirement when you're thinking about designing your electrical system. Really important note, if you're buying flooded lead acid batteries, you need to absolutely have what's called a leak-proof container. I mean, it needs to be a box that if you're going to pour water in it, that water would not be able to leave the container, because flooded lead acid batteries will eventually leak. They'll either leak because they got overcharged, or as they're aging, their ability to take a charge is, it lessens over time, and it's harder for them to get the same charge rate that they did at the start of their lives. And what happens is they heat up, and as they heat up, that electrolyte starts boiling out of the battery through the vent caps, and then it leaks, and then it will never evaporate. And it just simply collects at the bottom of the battery bank. I've seen battery banks with over 1 inch, 2 inches of sulfuric acid at the bottom. And the owners are telling me, oh, Jeff, it's water. I'm like, the rest of your engine room's not wet. you know, here's a good way. Like, how are we going to find out if this is electrolyte or not without touching it? And normally all our technicians, including myself, have a little bit of baking soda, and you've put a little bit of baking soda and you'll see the electrolyte, the sulfuric acid, is going to start fizzing. And that's a clear indication that you actually have sulfuric acid that is coming out of your batteries. It will happen. It's just a question of time, especially at the end of the life of the battery. At the beginning, should not happen, because that means overcharging. But at the end of the battery life, the battery at the end will not die just peacefully. Generally, there are signs that the battery is aging, and one of them is actually having electrolyte come out of the battery bank when you're charging. The other thing too that's really important, what I say here, and I emphasize this a lot, I go on boats and sometimes it's so sad to see that the battery bank becomes this distribution point. It's like almost like an octopus, right? It's like a rat's nest. It looks so, and I'm looking, this does not inspire confidence. It's essential that when you look at your battery, you have a minimal amount of battery connections at your battery, and all the connections, think about our cars. You lift up that hood in your car, how many connections are you seeing on your battery? You might see, for sure, 2, maybe 3, 2 on the positive, but at the end of the day, you're not seeing 20, 30 connections on your batteries. The manufacturers of those cars are doing what we're doing on boats as well. They're installing distribution points further down. They're putting fuse blocks. They're bringing one large connection, which is called a trunk line, from the battery to a fuse block, and then from that fuse block, they're fanning out. So it's very important to not have a boat where all the connections are at your battery bank. Again, if you're curious on the why, you'll find a lot of the whys in my 1 hour, 2 hour. We've got courses that are 12 hours long. So if you're curious and you're wondering, well, Jeff, why do you say that? And there's nothing wrong with being curious, and we encourage that. But for the purpose of this presentation, I can't always tell the why. So today we're going to be focusing on the what more than the why. And then the last point, which is really essential and often overlooked, is this concept of actually installing a battery switch. Unfortunately, as boats sort of evolve once they leave the factory, people add battery banks, but the people that add battery banks aren't necessarily electrical engineers. They're not people that have an extensive experience, right, in doing electrical. And a lot of them forget to put a battery switch on. And a battery switch is absolutely essential. So I've seen basically thruster banks that have no battery switches, which is a huge no-no. New house banks that can never be turned off. You know, they used to have 2 engine batteries. They installed a house bank. They didn't put a battery switch in. So it's very essential, and this is key. You have to have the ability of shutting down power from the loads to a battery, and you do that with those red battery switches. Now, it doesn't have to be red. Most of them are red. They're either black or red, and it's a big red battery switch, and you turn it so that you can actually stop the loads from being connected to your battery, okay? Really important. So the next thing we're going to talk about is this concept of power generation. What the hell is power generation? Well, it's the way of, I mean, it's one thing to have battery being stored, right? We talked about that. Batteries they're just a mechanism. It's like a wallet. It's your bank account. It's simply a means for you as a boater to store energy, right? But what about, how do we go about getting that energy back into a battery bank? And what we're going to be talking about is chargers, inverter chargers, alternators, solar, and then a little bit about fuel cells. Here's the diagram again. I'm going to be repeating this diagram throughout the presentation to start homing in and giving you a sense of familiarity with all the different pieces. So, all right, so here we have the battery charger, and notice the battery charger is connected to unswitched. Next, we've got an alternator connected to unswitched. Solar controller connected to unswitched. Battery isolators, which are connected to alternators as well, unswitched. Battery combiners, unswitched. And then we even have a methanol fuel cell unswitched. DC generators, wind turbines, unswitched. All these devices are unswitched. But what we're going to be focused on the next slide is the devices that create power so that we can recharge our battery and run loads from all these different elements on our boat. Okay, so with that, we're going to go on the next slide. All right, so if you've got a batteries, you're probably asking yourself, well, Jeff, how do I go about choosing my battery charger for my boat? You know, like 20 amp, 30 amp, 100 amp, 10 amp, 5 amp. There's so much choice. What's the mechanism to go about making that decision? Well, the first thing is you've got to remember there's sort of what are these rules of thumb, right? The minimum charge rate for a battery bank, and this applies for all batteries, flood lead acid, AGM, gel, is minimum is 10%. Okay, so minimum of 10% of capacity. Meaning, if you have a battery bank that is size at 100 amp hours, and that's the sort of unit of measure for a battery for capacity. It's not CCA, that's for cold cranking amps, that's to start the engine. But if we're talking about a deep cycle battery, we're now thinking about the amount of amp hours in a battery bank. You're talking about maybe 100 amp hours, 200 amp hours, you know, some boats 400, like 4 golf cart batteries in 12 volts is only about 400 amp hours. So it's not a big bank. You know, some of the boats that we work on have 2,000 amp hours, 3,000 amp hours. Most of us are going to be probably on a 30, 40 foot boat are probably going to have anywhere between 200 and 600 amp hours. But there are, of course, anomalies on the other side, but most of us are going to be at that 400, 600 amp hours on a 30, 40 foot boat, 10 meter to 15 meter boat. So if you've got a 400 amp hour battery bank, then the minimum charge rate is 10% of 400. So that is basically 40 amps. So you always want to make sure that your charger, and this is key, as you're increasing your battery bank size, you also have to think about increasing your battery charger. I've seen boats where the batteries were originally 200 amp hours, they went to 800, they had a 20 amp charger, and now they had a 20 amp charger to recharge an 800 amp hour battery bank. Right? That is a slow recharge. And what's going to happen is the battery is going to sulfate and will die prematurely because it's not charged at the right rate of charge. So this is really key. It's a huge takeaway. And most of us, if we have an older boat, the factories meet that requirement. The engineers that work for those manufacturers know this. But once the boat leaves the factory, if your boat has been upgraded, it's very likely that your battery charger has not been upgraded as the battery size was also increased. So have a look, go down, see, oh, how many deep cycle batteries do I have? What's my amp hour capacity? Okay, now I want to size my battery charger to make sure that my battery bank gets the minimum charge rate. And that minimum charge rate is 10%. Now, you can also, with these sort of batteries, also increase. Minimum does not mean that's maximum. And then the more you increase that charge rate, then the faster you can recharge your batteries. Now on shore power, that might not be so important because you say, oh, you know, I got a week, I got a day, it doesn't matter. But if you're running a generator, right, and you want to run the generator for a minimum amount of time, then having a large chargers, or chargers plural, because you can have multiple chargers, that is a way for all of us, for the boaters that have generators, to reduce our generator runtime so that we can recharge our batteries faster. And for AGM, what I'm highlighting here is that you want about 25% for flooded, and for AGM you can go up as high as 40. Now these are theoretical highs, right? So, you know, most of the time for AGM we're going to shoot for about between 20 and 30, and for flooded we might get about to 20. Sometimes we'll get to 25, but generally it's for flooded 10 to 20, and for AGM we'll go from 10 to 30. Okay? The question here is, the takeaway is this: as a boat owner, you have to ask yourself, how frequently, if you have a generator, am I willing to run that generator? And how long am I going to be running that generator for? Some of us, honestly, we're all different. Some of us run their generator 24/7 when they're on the hook. No problem. That's you. There's other boaters that say, hey, Jeff, you know what? I want to run my generator twice a day for an hour a day. Some other boaters say to Jeff, I want to run my generator once a day for 3 hours. You take that as a requirement, and then you size your chargers as a consequence of the rate at which you want to recharge your batteries. Okay, so charge rate is key, very key, and often overlooked. Okay, that's something when we do electrical audits, we see that a lot. Okay, so here we've got a schematic of basically a battery charger, right? Notice the battery charger is right here in the middle, and notice also the distribution for the purpose. And by the way, an electrical wire can obviously carry current in both directions. So does a pipe, right? It can go one way or the other way. But for the purpose of my conceptual diagrams, what I'm doing here is I'm trying to show you what is the direction or the current flow for a battery. So for example, here we have what's called a source selector. So a source selector would be for the boats where they have potentially shore, generator. Some boats have 2 generators, right? They'll have 2 shore. Some boats have a shore plug on the front of the boat, at the back of the boat. They have a generator 1, generator 2, so they have multiple shore, like AC source selectors, and that's right here. But the outcome of that source selector goes through an AC panel. And that AC panel is this device right here. So this is where you basically turn on loads, off loads. And one of those loads on an AC panel is going to be a battery charger right here. So that battery charger is a device that is powered from alternating current, and that alternating current can come from either shore power or generator. And then the output of that charger, and notice my little arrows, right here and right here, is going to basically take that AC and it's going to push out DC, right? So it takes AC, goes to DC, and they used to be called converters. Inverters are the opposite of that. We'll talk that a little bit later, but basically it's a converter. And so notice there's fuses. That's really important. Obviously, the battery charger is going to have a fuse at the panel, which is a circuit breaker, and that's basically what a battery charger does. Okay. All right, so what are some tips for a battery charger? You want to have what we talked about a little bit earlier. I know I'm harping a little bit on this, but this is key. If you want your batteries to last long, is you want basically minimum of 10% of your battery capacity as a charge rate for deep cycle. That's really good. You also want to make sure that you fuse the battery leads at the battery. It's very important. I see a lot of times people are fusing just on the output of the charger. The charger will never output more than it's rated for, ever. If it's a 40 amp charger, it's going to output 40 amps. The connections of the batteries are the ones we need to worry about. So you want to fuse at the battery, okay? And the important, I cannot stress that enough. If you want magic on your boat, you shall not listen to this advice. A battery charger has to be black and white connected to the unswitched distribution. Remember in this diagram here, I was showing when we started, unswitched distribution is right here, right? This is very important. Again, if you're curious on why, I've got another hour-long conversation on chargers. Remember, unswitched distribution. You cannot connect a charger to a switched distribution. Never, ever, 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 okay? Otherwise, you're in a world of hurt, Your boat is going to be this magical thing. Magic is not good with electricity. Nobody likes magic. So, okay, so that's really good. And the other point, the last point that I make here is this concept of an AC breaker size, right? So I've seen owners that increase the battery bank size, increasing the charger size, but then when it comes to it, the breaker is always tripping because the breaker was maybe 10 amps and now their charger is taking 20. So always make sure to size your breaker for the appliance, okay? All right, so the next thing. Here we've got an inverter charger. Again, similar concept, right? Where we have basically source selector, we've got the panel, and then basically here there's one thing that can happen. Power for an inverter can either go in with this concept of pass-through like this goes in, right? So that's called pass-through. So it senses AC and lets it through, or an inverter can take power from the batteries. You can see my little arrow, and then it can run. So an inverter takes DC power, creates AC, right? And they can be inverter chargers, or they can take AC in, and then basically they take the AC, and then this device can also go back this way if it's an inverter charger. In this schematic here, I'm showing just the inverter, but an inverter can also be a charger, okay? So if you've got an inverter charger on your boat, and here's an example, a reputable manufacturer from Washington State called Magnum, here are the things that you're going to want to do. By the way, if you have an inverter on your boat, the likelihood of you having a properly installed inverter on your boat is, I would say, less than 5%. Most of the installers would have never read the manual. It's just too big. It's over 100 pages. It's intimidating, and most people don't have time to read. They just want to do. So remember my stance, I'm really big. Educate first and then do. Plan, then do. Never do without education or planning. And education doesn't mean school. I learned everything I did on the job by reading forums, going on YouTube, doing all the buying books. Education doesn't mean a formal education. It could be a self-education. Nothing wrong with that. It's the way I learned. But you have to plan and educate. And here's the challenges with inverters. They're so thick, so complicated. Most people are just satisfied with it working. Just simply being, that's enough. And as a boat owner, you got to remember, there's more to just something working for it to be done right. And here are common things that are missed on an inverter. Generally, you're going to have the wrong fuse being used or no fuse at all. You're going to have no DC disconnect. So this concept of being able to disconnect the inverter from the load. Same thing with a fuel shutoff valve. Inverter only neutral bus. The chassis ground is wrong. That's the safety path. That's really important. The wiring to the inverter is the wrong size because they thought the wiring was too expensive, and they said, oh, well, do the people in the manual really know what they're saying? How can I maybe save? Or the wire's too big, it's too heavy. All of these things here, all of this list are the common pitfalls that you'll see in an inverter charger being wrongly installed. Again, articles, videos just on this very topic. So if you're thinking about an inverter charger for your boat, go down the rabbit hole, geek out, and learn about it. It's one of the trickiest electrical appliances you can install in your boat. So knowing this, don't be surprised if it takes long and it's a lot harder than it seems. It's normal, it is hard, and it's okay. It's a boat. It's not supposed to be easy. All right, so the next one. Here we've got alternators. Notice here, this is a kind of neat. I show this all the time. Most of our cars and boats are wired here on the left-hand side. And I'm circling it. This is basically how most boats are actually wired. You can see the alternator goes basically to the starter solenoid, and then from the starter solenoid goes to the on-off switch, and then from the on-off switch to the battery. That's the direction of the current basically for that alternator, right? So it goes basically like this. Some people, right, are actually going from alternator down to the battery direct. There's pros and cons with this. Certainly in my boat, I went with this, less single point of failures, and I ended up removing this battery switch, which can be a lot of pain. And so my starter is obviously directly connected to the engine battery, but my alternator is connected not to my engine battery. And most of the time on the boats we work on, we actually reroute the alternator potentially to the house battery bank, the one that needs the most charge. But that's something custom, something to think about when you're thinking about your electrical system. Size the alternator, of course, to the battery bank size. That's very important. A lot of people increase the battery bank size, keep a tiny alternator. The alternators keep dying. They're working too hard. So sizing the alternator based on that rule, 10%, 20%, all those tips are really important also for an alternator. And making sure if you're going to increase the size of your alternator, you're going to want to make sure that you increase also the wire size so that the wire doesn't overheat as there's more amperage, right? So that's another big takeaway is sizing the wire so that it can handle the increased amperage coming from that alternator. And lastly, if you're going to modify your alternator to be a little bit like what I did, which is this right here, where I'm saying, okay, here, I'm actually going to notice I have a fuse right here. So that if ever something happens at the alternator, the fuse is actually going to be positive. And it's the fuse not being positive, but the positive wire is fused. And if there's ever something bad that happens at the alternator, you're not going to have a dead short, which means a fire. Okay? All right, so next page, we've got solar. Notice here I'm showing different types. You can wire panels in series, in parallel, or single. And notice what I've got here is there's a controller, right? So even here, we generally wire panels in single to controller, like I've got here on the left-hand side, or on the right-hand side, you've got solar panels in series. At the end of the day, all solar panels need a controller. You need an ability to adjust the voltage for what the battery needs, and that's right here, an MPPT controller. We've got one here too. And that's basically it. It's not too complicated. But here's the trick, right? When you're going to be looking, so you're looking at your solar output, people tell me all the time, Jeff, well, how many amp hours can I expect out of a 100-watt panel? Well, the rule of thumb is actually pretty straightforward. It's a factor of 4. So if you've got a 100-watt panel in the summer months, when the sun is shining more than in the winter months, you can actually get basically out of a 100-watt panel about 25 amp hours. 25 amp hours is what you'll get out of a 100-watt solar panel. Now, that's on average. It's not, you can get better than that, you can get less than that. Of course, if it's doomsday and it's raining super hard and the cloud covers are thick and you can barely, it's dark outside and it's daytime, naturally you're not going to get at all what you would have hoped for. But if it's a beautiful sunny day, you'll get better than a factor of 4, but on average, it's a factor of 4. Some tips to consider, when you're buying a controller, are you buying a controller for batteries that are 12 volts or 24 volts? That's an important one. I've made that error before, not realizing, is this a 12 volt boat or 24 volt boat? So think about that. What is going to be the maximum voltage array coming out of that array, and also the amperage? That's another big factor that you want to think about. What kind of battery chemistry are you going to have, right? Like, are you going to be charging flooded lead acid? Are you going to flood AGM? Is this a lithium battery? Is this a custom? So those are factors too when you choose your controller. And then deciding, okay, well, am I going to have one controller for a huge array? Am I going to have a controller per panel? I tell people if the panels are going to experience shading, then you're going to want to have a controller per panel. If the array is not going to be shaded, then you can consider having one controller for multiple panels. But then at one point, you've got to ask yourself, maybe the input voltage is too high and it's starting to be dangerous. If you've got 100 volts, 150 volts of DC coming in your boat, that might be a little bit worrisome. So that's another factor when you're going to be deciding how many panels are you going to be connecting to a single controller. And then lastly, of course, I'm a big fan, as you saw, fuse, right? And you can see that I've got here on the diagram fuses connected at the battery. Victron, for example, and these are Victron controllers, also even have little fuses actually in the controller, and those fuses are between the controller and the solar panel. Okay, so next, I'm going to show a little bit here a methanol fuel cell. Not for everyone. This is a device that converts methanol to actually a DC charging amperage. Device here, it's not a big device. They weigh about 30 pounds. We've done a lot. I have some. I have one on my boat. Done lots here in the Pacific Northwest. Again, not for everyone, but there is some boaters that find this to be a useful tool to recharge their batteries. And you'll notice that it basically has got a bunch of connections, but the methanol fuel cell, of course, because it's a charging source, needs to be connected to what? The unswitched distribution. Okay, unswitched distribution, really important. Ventilation is really important when you're going to be considering a methanol fuel cell. It outputs, of course, distilled water, so that's something to think about. All right. And then you're going to want to make sure that you size the cabling depending on the distance from the fuel cell to the battery. Okay, so something else to consider. All right, power sharing. So what are the power sharing devices? Well, remember, we've got, you might have on your boat just one alternator, but you've got two battery banks. Well, how are you going to have one alternator charge two battery banks? You do that through basically two devices. One is called the battery isolator, which is right here. And then another one is called the battery combiner, okay? And we're going to talk about that. All right, so here we've got a battery combiner. Notice the battery combiner is right in the middle of the slide. And here's a takeaway. Notice how the arrows are bidirectional, meaning current can go this way, or actually current can go the other way. So a battery combiner, for the most part, some of them are directional. They do exist. But for most part, most battery combiners allow current to go either direction, from either engine battery back to house battery, or from house battery back to engine battery. So here's an example. Your alternator is working, comes out, goes to the engine battery, through the battery combiner, out to the house battery. Or you could have, for example, solar is charging your battery, goes back, charges the engine battery. So here you've got basically the path goes both ways. That's a battery combiner, okay? Again, tons of slides on battery combiners, videos on battery combiners, very popular device. So when you're choosing a battery combiner for your boat, what are you going to be looking for? You want to make sure you see, well, what's the amperage that I'm going to be buying? How much current is going through that? Common models are, 55 amps, 120 amps, 300 amps. You can see that. You want to make sure that you fuse at both ends of the circuit. You saw that on my slide. Big fan of fusing, safety first. You've got fusing right here. And notice how the fusing is at the start of the circuit, and the start of the circuit for battery combiners are at the batteries or the unswitched distribution. I see a lot of people sometimes installing the fuses right at the battery combiner itself. That's the wrong place. That's only going to fuse about this amount. You really want the whole circuit from battery to be fused. So that's a big takeaway as well. Okay, that's about it on that front. The next one is the concept of a battery isolator. Notice how this one is interesting. The alternator comes in and then it basically goes to two places. So here's the path flow. Comes in through the isolator, through the battery, goes also from the alternator through the house battery. But notice that the directional arrows here don't allow current to go from the engine battery to the house battery or from the house battery to the engine battery, meaning it's not a combiner, it's a directional device. There's an input and there's an output. So the input comes in and then you have an output that goes to the engine battery and to the house battery. And the beauty of a battery isolator, and it's one of my favorite sort of electrical devices, is that it doesn't allow engine and house battery to see one another. So you know it's predictable how much current is going to flow through this device because the maximum current that can come through is limited by the alternator size right here. So that is called a battery isolator. Again, we have a whole web, not just web page, web section just on battery isolators and pros and tips, and everything about how you go about installing that on your boat. Again, same concept about fusing. Remember how fusing is important, right? We talked about this, right? Fusing is absolutely essential. The fusing is right here, fusing is right here. You can't, of course it's going to work without a fuse, but if ever you have a problem, you're going to get yourself in hot water if you don't have a fuse on a circuit. So you're going to want to fuse the alternator leads at the batteries. You're going to want to size, obviously, the alternator cable to be able to handle the amperage that comes from that device. That's really important. I see people sometimes taking shortcuts and then the wire ends up melting. It's pretty scary, and so you want to avoid that. There's no need to be scared on a boat with electrical. So that's the next things. And with that, I'm going to give an occasion, I'm going to wrap a little bit everything up. So if your takeaway from this is, oh my God, this is overwhelming, welcome to the club. When I started years ago, felt exactly the same way. Remember, educate, plan, and then do. So that's okay. For some of you that are local, you've got an opportunity. We offer electrical orientation where we do a walkthrough on the boat. We also do the same thing for electrical audits, a little bit different. We started with a presentation, and if you ever are sort of overwhelmed with all these choices, please feel free to reach out. We offer these consultation and design services. If you've got a simple question, post it on YouTube. We answer almost 4 of those questions a week, sometimes more. We don't get, unfortunately, a chance to answer them all, but again, there's a lot of those questions might have already been asked by fellow boaters because we have similar problems. That's something else to consider. And then also be able to find all our content on our website. Everything that we've ever written or published is actually available there as well. So that's really good. And here I'm going to close and I'm going to give a little wrap up everything what we talked about today. I want people to really get a sense, got a few minutes just before. So what we talked about, we said batteries, right? What are the batteries? The batteries are our ability to store energy, right? It could be a house battery, an engine battery, thruster battery. You're going to think about battery chemistry, battery size, right? Is it flooded? Is it seal valve regulated, AGM? Is it a lithium? Is it Firefly? How frequently are you going to charge that battery is going to affect the size of chargers that you're going to have on board, right? So we talked about chargers right here, maybe even your alternator. We've got solar controller, we've got methanol fuel cell, we've got wind turbines. Those are all different ways for you as a boater to recharge your batteries. That's important. And then we're going to have ways of sharing that charge. Maybe a battery isolator, a battery combiner. And notice here on this diagram, we even have an inverter on this side. That's basically a load. You've got your panel here, and then you've got your fuse block. And the big takeaways as well, we talked about this concept of magic. Charging circuits have to be connected to the unswitched distribution right here. And then basically loads have to be connected to the switch distribution right here on the right-hand side. And if you're wondering why there's 2 fuse blocks, one on unswitched and one on, here's the unswitched one, here's the switch one, why is there 2 fuse blocks? Well, some loads on our boats have to be unswitched, like a bilge pump, carbon monoxide detector. It could be, some people even put their VHF as unswitched. Very few loads are unswitched. They're generally safety equipment items, but then everything else becomes switched. And that's why you have the concept of switched and unswitched distribution. With all of that, I want to thank you for sharing my enthusiasm and passion for boating. I want to wish all of you a really amazing 2021, and hopefully we'll all get a chance to see you on the water. So thanks for watching.
All right. Well, thank you everybody for your patience. Somebody said boaters are patient. I'd like to add boaters are gracious too. Those were some unfortunate technical issues in the beginning of the presentation, but I'd like to say we had good retention. So Jeff managed to keep all of you here. Thank you all for attending. Thank you for joining the boat show. And I'd like to mention our sponsors as well, Freedom Marine Yacht Sales in Vancouver. Please make sure that you check out all the features at VIBS, like the info booth. I hope you have a great rest of the show.
Oh yeah, the season starts.